Alrighty. So once again, welcome everyone. Thrilled to see so many of you here today. See some familiar names in the list here. So this is another session in Kaitera's webinar series. My name is Joe from the Kaitera team. I'll be hosting today as we take a deep dive into some really important and interesting new research on indoor air quality and its effects on cognitive performance. But first, those unfamiliar with Kaitera, just a little primer about us. We do produce a suite of air quality monitoring and management solutions. We help organizations across the globe create world-class healthy workplaces, help them optimize building performance, or achieve healthy building certifications like WELL, LEED, FitWell, and RESET, among others. We do offer this webinar program just like this one throughout the year, so be sure to check out the events page for upcoming sessions or sign up for our email communications so that you can be notified of the next session right to your inbox. So again, if you're just tuning in, welcome everyone. Thanks for joining us today. I'm really excited for today's conversation. I think you're all really going to enjoy this one as well. We're here to explore something that's often overlooked but deeply important, which is how the air around us can impact not just our health or comfort, but our ability to think creatively, solve problems, and perform at our best. If you're involved in workplace design, building operations, or even real estate strategy, this conversation is especially for you. But if you're not, I promise it will still be just as interesting. So today we'll be unpacking some fascinating new research on indoor air quality and cognitive performance with a spotlight on creativity and what that means for the way we shape our indoor spaces and work environments going forward. So today's session will be led by Kaitera founder and CEO Liam Bates, who also serves as well faculty and can be often found in one corner of the globe or another, lending his expertise by frequently speaking at international conferences on air quality monitoring and management. We're also absolutely thrilled to be joined by Dr. Sandra Dedesko, an expert at the intersection of building design, environmental quality, and human performance. She's a researcher at EPFL's Human-Oriented Built Environment Lab and completed her PhD at Harvard's Healthy Buildings program. So she's dedicated years to studying how the built environment impacts the way we think, feel, and perform. Her research has uncovered some fascinating insights into how IAQ factors don't just affect our comfort, but also our ability to be creative and solve problems. So this has huge implications for the way we design and manage buildings, especially in workplaces where innovation and productivity are key. So this is going to be such an interesting conversation, and I promise we'll get started in just a second after I cover a few housekeeping items. So just a couple of quick items so we make the most out of today's session. The webinar is live and will be recorded. It'll be made available on demand. We'll follow up via email with the recording as soon as that's available. The session will run for approximately 1 hour, 40 to 45 minutes of content, followed by Sandra and Liam answering any questions you may have in the remaining 10 to 15 minutes. You can send in your questions at any time during the discussion via the Q&A tab at the bottom of your screen. We'll collect them and answer as many as we can during the Q&A portion. Please also join in on the conversation. If something resonates with you during the discussion, feel free to comment in the chat. We love to hear your thoughts. Okay, so during today's webinar, we'll be discussing several topics, which you can see listed out here on the screen. And with that, I'd finally like to pass the virtual mic over to Liam to officially kick things off. Thanks, everyone. And Liam, over to you.
Amazing. So thanks, Joe, for the intro. Obviously, welcome, Sandra. Welcome, everybody, to today. And I think this is going to be a really fun session. This is not a presentation. There is no series of charts and graphs and very fine print to look at for the next 45 minutes. This is really just a conversation where we are going to chat about the latest research, learn how it was done, what the outcomes were, and I absolutely encourage everybody to participate. So as Joe was saying, that's why we've got the Q&A box. If you do have questions along the way, just go in there, add your questions, and we'll get to them at the very end. So I'm really excited about this. I have read and looked through a lot of research around indoor air quality over the years, but maybe to kick things off, Sandra, we can just start with a bit of your personal journey. You know, what drove you to get into public health, indoor environments, all the science around this, and especially kind of this unique area of cognitive performance and the built environment?
Yeah, well, first of all, thanks so much for having me, and thanks everyone for joining today. A bit about my personal background. So I started in civil engineering, focused on building science, or more on the like sustainability side of high performance building design. And then I was actually introduced to Jeff Siegel. He's a professor at University of Toronto. I'm from Toronto, who focused on indoor air quality and the impacts of buildings on health. And so in his lab, I started working on different projects that examined different aspects of indoor environmental quality and how those link to different aspects of health. And at the time, I was like, wow, like this is some very exotic engineering research. But as I learned more about it, I was like, oh, there's like an environmental health, a public health aspect to all of this work. And then after my master's, I worked in industry, the sustainable design industry, for about 5 to 6 years in different roles. And as I was really trying to get health more integrated into my work, I found myself interacting more and more with people and groups from public health. And then eventually it became pretty clear that this group seemed to know something really valuable to building design. And if I wanted to bring that into my future work, it seemed like a good idea to go get some formal training in that. And so Dr. Joseph Allen's Healthy Buildings team at Harvard was like the perfect opportunity to do both the public health training while still focusing on the buildings topic, which I'm so passionate about. Yeah.
And that obviously is where all of that COGfx research comes from. I'm sure a lot of people saw a lot of the names that are on the webinar today, and there's many familiar ones. Many I know are intimately familiar with the COGfx study, can probably recite many of the numbers from these, I guess, studies, plural. But for those that aren't familiar with it, what is COGfx? What is it? What has the previous research been all about?
Yeah, so I was one of those people actually when I was still working in design that was fascinated with these studies. And I thought it was maybe just me, but I was really surprised to see people in the industry and like people at my company also bringing up these studies and the research findings. I was like, okay, this is very interesting. You don't usually see academic papers have such interest and impact. But I guess to summarize it, and I should not take credit because I wasn't involved in the early studies, but there was, I would say, three beginning studies that really charted the COGfx series in that group. So the first one, I think, is probably the most famous, where it occurred like in the lab or the simulated office environment, where the research team was able to alter different aspects related to indoor air quality in this test facility, and then assess different aspects of cognitive performance among these office worker participants. And they found really striking findings between better indoor air quality, and higher cognitive performance scores in these different domains. From that, they built upon this with a study that took place in paired office buildings throughout the US. And then from there, they also built upon that with a global study where they deployed sensors in over 100 office buildings across the globe and monitored associations between these different exposures and these different cognitive outcomes. And again, found this consistent theme of better indoor air quality being linked to higher cognitive performance measured in different ways.
Yeah, and I think, for many of us that are working in the realm of indoor air quality, we've cited a lot of these studies and
Mhm.
sort of the outcomes that better air, more ventilation, fewer particulates, all of these things lead to better productivity outcomes. I think the latest research that you've been doing is have really focused on creativity, which is,
Mhm.
I mean, I'm not an expert in the field of productivity, creativity, and the differences between all of these, but it's a little bit different from sort of the historical productivity metrics that we're looking at. So, I mean, I guess, well, first of all, like, why creativity? Why is that the area to focus on versus all the other areas of cognitive performance?
Yeah, it's a really good question. So part of it is what you said, that so many people have focused on these more like objective measures of cognitive performance. And so a lot of that is like speed, accuracy, like information usage. And so as a researcher, those are really nice. They're far easier to measure, but they don't get at the whole picture. And I think that's been a lot of the discussion around these findings. Like, okay, very interesting, but like, how does this relate to work in the real world, like in an actual office? And so we are interested in creativity because number one, it's understudied. Number two, it's an increasingly sought after skill by a whole range of companies, work type. And I think as things get more and more automated, that type of creativity and creative thinking that people can bring to different problems and industries is becoming more valuable. So we didn't see much research done in this space and wanted to try to measure it and then also see if we can find this link between indoor exposures.
Yeah, I mean, it's kind of and I don't claim to be an expert in this, but
Neither do I.
and so just like thinking aloud, when I'm thinking about the decisions in many ways that impact a business to the most, it's a lot of those decisions, it feels like, are very strategic, creative, and not necessarily what certainly many studies that I've seen over the years, a slight increase in speed of completion of tasks. I mean, that's great. If people can do things 5% faster, sure, that's awesome. But if you can have a totally out of the box idea that revolutionizes your business, that seems like something that we should absolutely be spending more time studying and understanding. So yes, I love that, and I think it's also really important that, you know, when we are looking at things like measurements of air pollutants in buildings or trying to understand the performance of a building, there's more and more language available to us to be able to sort of translate that into the metrics that matter to business leaders, the people that are actually paying for these large buildings to be built, because they're a lot more concerned about creativity than CO2 levels, for example.
Mhm.
It sounds really hard to measure creativity. So maybe a dumb question. How do you measure creativity? What does it even mean?
Yeah, it's a great question, and it is really tricky. So I have more appreciation for those more objective measures, but I'll back up a bit. Like, what does it even mean? So I think this was actually a nice part of the study for me personally, because I'll bring my mom into the picture. She's a painter, like she's a visual artist. And so like before this, I'd be like, oh, my mom's the creative one in the family. But I would argue as an engineer, I'm actually very creative myself, maybe just not in the way we traditionally think about it.
Mhm.
So there's different types of creativity. The one we looked at, and this is, I'm sorry to everyone listening, this is divergent creative thinking, which is ideation to problems with no standard solution. And what that actually means, yeah. So it's basically like an open-ended question. There's no right answer. And it's, we're trying to assess how capable participants are of finding different creative solutions to the problem when there is no correct answer. So that is tricky, I think, for us as researchers to wrap our head around, even to explain, and then trying to measure it is a whole other thing.
Yeah,
Fortunately,
how do you measure it?
fortunately, yeah, I'm having flashbacks. There are some standardized tests. So we use something called the Alternative Uses Test, AUT, and that's a validated assessment of this divergent creative thinking metric. And so at Dr. Allen's team, we have a custom built smartphone research app where we can send these tests to participants at different times. So we gather the raw scores, and for anyone super interested, the way the test works is, let's say I'm doing it right now, I would get a prompt of an everyday object. So it could be brick. And then I have 2 minutes to come up with as many different uses for that item as I can think of. So it could be like doorknob, it could be side coffee table. You get some really creative ones, let me tell you. And then it's a bit of a tedious process. So first we try to clean and parse through all of the responses and the words with code to keep it objective. But then we have to bring in a whole team of scores. It was 2 blinded independent scores and then myself as a reviewer. So we have to go through also to look at things like, you know, does the response even make sense? Can we even make sense of this string of characters? And so once we get through all of that cleaning, then we have these 4 different creativity scores. They are fluency, elaboration, flexibility, and originality. Should I keep going? Yes? Or, yeah, okay.
I'm learning, this is fascinating.
Okay. So I'll give you a brief overview. Fluency, that's the number of distinct ideas generated. Elaboration, that's the level of detail per idea. Flexibility, this is now the number of distinct use categories. So you might get 8 different uses, but like 5 of them might fall under cooking and 3 of them might fall under like arts and crafts. So then we have to come up with these different distinct use categories. So that person that came up with 5 cooking, 3 arts and crafts, they get 2 points for their flexibility score. And then on top of that, we have originality, where we look at the number of distinct use categories per everyday prompt compared across all participants. So what makes things even more challenging is if you look across the literature, like people will score these metrics in different ways. So surprisingly, it's actually not that consistent or standardized. So you have to keep that in mind when comparing. And then other groups will bring in additional metric that looks at like the usefulness of idea, which adds like another layer of subjectivity among the scorers when they say like, how useful do I think this proposed use is for this everyday object? So yeah, we try to keep it as, I would say, objective as possible with code where we can, but there is quite a bit of a subjective human nature in the scoring.
It sounds like it's kind of part of creativity. So yeah,
Exactly. And I have to give a shout out. We had two interns that really they were keen to take on the task, and they did a phenomenal job. They're the second and third co-authors on the paper.
Amazing.
Yeah.
So I guess at a high level, I mean, I think one of the things that a lot of people struggle with is that indoor air quality is very complicated. You've got all sorts of different parameters. You've got CO2, particulate matter, temperature, humidity, the sort of air movement, all these things that impact thermal comfort. You've got light, you've got noise.
Yeah.
How do you isolate this down to a single variable, right? An increase in X led to a change in Y% on creativity.
Yeah, it's really tricky. And so like the study we're talking about right now, this is observational. Like we're just observing what happens in an operating building. We're not coming in and controlling different levels of these indoor parameters. So fortunately, when you're not doing a controlled or an experimental study like that, when you're just observing what's happening, there are different statistical techniques that I learned a lot about in public health yeah, maybe too much, careful what you wish for, that allows you to control and isolate for some of these things. And this is also really helpful because not only with these statistical models can you control for these confounding variables that could introduce error or like bias into what you're modeling between like an air pollutant and a creativity score. But it also allows you to understand the scenario in a way where certain things like light, even though it might be important to the score, the outcome, it might not actually be related to your air quality exposure in that case. So it actually wouldn't bias your association there. So provides like a really nice framework to understand your study and then also to help control for what you need to control for to isolate those variables of interest.
Got it. Okay, it sounds like if we're gonna get the weeds out, we'll need another webinar specifically for.
Yeah.
So I guess maybe we've talked a little bit about the how and the process. How do you measure this? It sounds like, and just to sort of clarify that this wasn't the process of pumping CO2 into the room and watching what happens. This is really observational. What were the observations? I guess what were the wow moments? What really surprised you and was unexpected? And I guess maybe this is also a great moment to talk a little bit more, actually put a few numbers in here. I know we said we're not pulling up graphs and looking at charts, but what are those numbers that people can walk away with that were part of the wow moments or the surprises?
Yeah, I mean, I'd say I have many surprises myself. I think there were two big takeaways for me when I was working on this analysis and running these models. The first is, if I'm taking like my scientist hat on or taking it off, sorry, for a sec, and just thinking about the situation, I'm like, creativity scores, like, am I actually going to see an impact from these short-term exposures on something like creativity, which I think a lot of us think as something that's like more inherent to us, like something that's not maybe so modifiable. And the second thing was when I was observing what was happening in these buildings, this is great from a building operation perspective, but from a researcher, when you see such low concentrations of CO2 and fine particulate matter, you're like, darn, like I might not see anything in these models. Like, again, great for operations and health, but from a statistical modeling perspective, you're like, I might not see anything over these.
What kind of numbers? Sorry, just to interrupt. Just what kind of numbers are we talking? You're saying low concentrations. What sort of range was this for the academics and nerds in the chat?
Yeah, I mean, we have like the full summary statistics in the table, but most of the CO2 concentrations were below 900 parts per million. And for PM 2.5, we're seeing again, like, I think most of them like 90th percentile below 10 micrograms per cubic meter. So we were looking at a fairly low range. Like, to give you an example, in one of the previous COGfx studies, actually the larger study from this portion of data I was using, they had a much higher power data set. And when they were looking at different associations, they only found statistically significant results above 12 microgram per cubic meter of PM 2.5. So the range I was looking at, I was not expecting to see anything. So back to your original question, like the wow moments, when we were running these different models, we saw this consistent, I'll say like directionally consistent, where you see just the direction of the increase or the decrease following the direction of the concentration. So starting with CO2 across the board, we see that when there's a 100 part per million increase in CO2, we see this consistent decrease in 3 of the 4 cognitive scores related to creativity. Elaboration, we also saw a decrease. What that means, though, is it's a bit up for debate, and we can chat about that more later. But the overall narrative was that when we see this increase in CO2, we see this decrease in the different creativity scores. And then we actually saw the same thing for PM 2.5, but the results didn't reach statistical significance. They did for most of the CO2 scores, which was even more surprising, like I said, based on the low concentrations we were looking at.
So these are, I mean, translating some of this for some of the real estate workplace leaders, sustainability consultants that I know are watching. These are levels that typically would absolutely be considered good air quality. They would be meeting the healthy building standards out there. You know, if you had this on a dashboard, it would look like everything's green. And what you're saying is within this range of already good, you're actually seeing statistically significant impact on many or most of those creative functions.
Yeah, and this was echoed
really
in that earlier, COGfx work where, again, like I was jealous they had that much higher power data set, and they see this like, linear, no threshold effect of just increasingly low CO2 and increases in the different scores that they looked at. So I just thought it was really striking that in our lower concentrations and for creativity now we're seeing the same narrative.
Yeah, were there any results in here that, I mean, these sound like surprises. Did anything in here sort of fundamentally shift the way that you think about what good air quality should be, how you think about ventilation in buildings? Did any shifts in perception here?
I mean, I've always been on the like ventilation, good indoor air quality bandwagon, but I will say, like, I think it was like a whoa moment for myself where even like we're talking about these concentrations that would be considered high performance. We are seeing this growing body of evidence that's saying like the better you can improve the indoor air to, I mean, with CO2 down to atmospheric levels, the better the performance. I think I always feel almost like, I don't want to say guilty, but a bit cautious about that too, because I know we have energy concerns around to balance with ventilation. So I think there's still a larger discussion there.
Yeah, well, I mean, it kind of reminds me of many of the sort of statements from the WHO where people always ask things like, what's an acceptable level of PM 2.5? And, the answer is, well, there is no safe limit, right? It's not like magically you get under 12 micrograms or 10 micrograms or 5 micrograms per cubic meter and suddenly it's like, oh, okay, like this air is awesome. No, any level is bad. It's a question of, how do you balance things like energy, filtration with that. So I don't mean to try to condense a lot of scientific work into sort of one line or something, but I mean, we've said that there's a statistically significant change in creativity. Well, how big is that? Is it something for, let's say for a business leader who's watching this and they're saying, okay, I understand lower CO2 equals my people are going to come with much more creative decisions. They're going to do a lot more creative things. How much more?
No. Okay. Scientists don't like this question, but
I'm sure you're gonna love this question.
I would say, like, if I'm taking my super formal scientist hat off, like from this study, we can say that you could expect up to like an 11% increase in one of these in a creativity of your employee for that 100 ppm increase. It's gonna, okay, scientist hat back on, it's going to vary. Like you will, if you go into the table, you'll see there's variation in that range, but you can say you could expect up to an 11%.
And 100 ppm that is not very much. I mean, as speaking as somebody that spends a lot of time looking at a lot of building data from all across the planet, if atmospheric levels are just over 400 parts per million, there are a lot of conference rooms that are well over 1,000 parts per million more than that. I mean, I see a lot of schools where, unfortunately, you're seeing 3,000 ppm of
Yeah.
CO2 in classrooms, which, yeah, that's that's a lot of percentage points away from that sort of 400-ish baseline.
For sure. I mean, Joe and I were joking, like this box I'm in right now, the quality of this webinar is probably going to go quite a bit downhill very soon.
At least it's going to be less creative.
Exactly, right? But no, yeah, to your point, like, I mean, this is just one study. We do see like scientists have back on like variation in the effects for sure, but I do feel like there is this consistent bulk of evidence showing the benefit of improving ventilation at
Yeah.
these different ranges.
Yeah, and I think something else maybe for a lot of people working in this industry to think about is also how to make sure that, be it across the country, across multiple offices, globally, you are putting in place policies that allow for these spaces to be, and your employees to, I guess, work in a more equitable manner. This is something certainly that I see and have a lot of conversations with workplace leaders about, which is you see massive variation in particulate matter, CO2, all of these factors based on obviously the geographic location, the way that buildings have been constructed, the way that ventilation has been designed, where you might have employees working out of an office in Asia, and those numbers are going to be 3, 4, 5, 10x higher than they might be in Switzerland.
Mhm.
Saying Switzerland because that's where I come from, and that's where you are right now.
Yeah.
But yeah, so I think this is it's obviously a great argument for why we should actually get data on these things, understand, and be able to prioritize spaces that maybe aren't performing. Because I think it's very hard for me or you sitting in a room to you can't sort of do a sniff test and go, okay, this room's at 800 ppm. It's
Yeah.
incredibly hard for a sort of human being to tell, but from your research, there are pretty major changes in the outcomes from people in these different spaces. So yeah, something for all of us to think about. Based on everything that you have uncovered, are continuing to uncover, how should we be thinking differently about designing workplaces?
That's a great question. I think I always try to think of, the hierarchy of good indoor air quality. Like we have all of this evidence now. One of my colleagues here says, like, indoor air quality is kind of like a universal experience. We see this very consistent pattern of better indoor air quality, higher cognitive performance. With thermal conditions, we see a lot of individual variability and whatnot. So I think indoor air quality seems like a really promising place to focus. And there is this kind of traditional hierarchy where we start with like source control. So that's not introducing pollutants into the space when we can. That makes our lives easier. Then we move on to ventilation and then filtration and air cleaning. So that could be something like for a lot of operating buildings. And when I was working in like design and consulting, this could be really tricky for existing suites. Like, oh no, how do I now make a change? Like I don't have access to the ventilation system and whatnot. So paying attention to things like material selection, like purchasing, or if you're doing a renovation, like these lower emitting materials with better ingredients. Then we move on to ventilation. And when you can, like if the system allows for it, to increase those ventilation rates. And then finally, good filtration with like validated like media filtration that has these industry tests can help further lower like concentrations of the particulate matter that you're referring to, or even standalone air cleaners, depending on the capacities of the systems. But yeah, I think always like following that hierarchy, which you could do in an office place, you could also do it in your own home. Like I know I do simple things like turning on my range hood to full blast when I cook and not bringing in fragranced products into my home, although that one can be kind of tough for a lot of people. So
Yeah, well, so the range hoods is yeah, that's a fun one because it's one of there's a recent study from LSE actually that was looking at basically the impact of users being able to see indoor air quality data and the changes that they take. So when you're able to see the data and you suddenly see that when you're cooking your steak, suddenly the numbers go up.
Yeah.
And a lot of people have never really used the range hood,
I
or
know.
you put it on low. I always used to turn it on while cooking,
Yeah.
and the moment that you're done, turn it off. But the
Mm.
reality, having now spent many years in sort of looking at the data in my own home, is that you realize that the moment you're finished cooking, you're
Yeah.
actually at the highest level of particulate matter and many other gases, right? That might be coming
Hmm.
from the cooking process. And so if you turn off the range hood at that exact moment,
Yeah.
well, now you're just stuck at sort of the peak level of many of these pollutants. So actually, pro tip for anyone watching, like
Yeah.
keep ventilating for a while after you're done with your cooking. And I think we see the same thing in many buildings around the world. And having transparency into the actual information and seeing the numbers allows you to obviously start making more targeted fixes. A recent example comes to mind where you were just talking about balancing sort of energy savings, ventilation, versus ventilating as much as possible to have as low numbers as possible. I've seen a lot of really interesting examples of demand control ventilation either doing a great job, so bringing in fresh air, or okay, it's not always fresh, we'll call it outdoor
Yeah.
air,
Yeah.
outdoor air when needed. But then I've also recently seen quite a few extreme examples where the parameters have sort of been tuned so finely that the moment somebody leaves a room, it stops bringing in fresh air, and you see things like somebody coming in and cleaning at night. VOCs suddenly shoot up.
Yeah.
Then no fresh air is brought in until the next person comes in. And so overnight, you've just got these sort of chemicals sitting here in the space until the first occupant comes in. And then that's when the ventilation kicks in. And that's obviously not a space that's optimized for productivity, creativity, or just general comfort and well-being. So yeah, definitely understanding the relationship between these things. I think being able to see the data, having this sort of hierarchy that you can follow and say, well, this is the low-hanging fruit. Get some of those sources. That is absolutely the way to go.
Totally.
Looking forward a bit, this was obviously a big piece of research. What's next? What are you and your team up to?
Yeah, good question. Actually, maybe I bring up the range hood topic. That's a hot
Yeah,
topic of
yeah.
conversation here in the team. So right now it's early days, but we're discussing maybe a group project on that. And I think there's too many research questions like going in different directions. So we're still in the planning phase, but we're curious to investigate things around range hood use, policies, maybe user behavior as well. So everything you said was of super interest to all of us. And then for me personally, I'm still very interested in the cognitive space, but I think like we were talking today just about one study from my dissertation work, but there were two others also looking at this topic. And again, like finding this narrative between indoor air quality, um, thermal conditions, and cognitive performance. And I think even though it's a consistent theme, what I said earlier, now trying to figure out where the energy piece comes into play and how we can balance that. So that's something I'm excited to dive into here, is trying to understand the potential to save energy and hopefully tie that in to the air quality promotion piece.
Yeah. Very interested to hear more about that. It sounds like a really tricky problem to solve. It's already hard enough, just I feel like looking at the air quality space with all of, or let's call it the indoor, environmental quality space with all these different parameters and things that can impact human performance. And then we've got to balance this on the other side.
Yeah.
Or maybe not necessarily on the other side, but just as another factor to take into this. It sounds extremely challenging. So I look forward to seeing the results of your work.
Me too. Thanks.
What's sort of one, I guess, zooming out, big picture, what is one thing that you wish more could be business leaders, architects, designers, engineers, policymakers understood about the relationship between indoor environmental quality and cognitive performance?
Yeah, I guess I've probably already, I'll go back to what I said just a little bit earlier, but it really does make a difference. Like I know even myself, right? Someone that's been researching this topic for many years, but like even when I came to do this creativity study, for example, like we were just chatting how surprised even I was to see these very consistent, statistically significant results. And I think as I was doing this work, I was like, wow, it really does matter. Like there really is like a measurable effect. And this was one of the reasons why I specifically did the public health degree, was to try to understand how to quantify or like demonstrate this estimated effect, to try to bring it forward for change, whether it's at the policy or the building level. So I think I'm fairly convinced, like I'm quite convinced that there is an effect. We can now demonstrate it in some ways. And so I think it is important that we do take this seriously and act. And because we are seeing this kind of universal indoor air quality experience, this consistent improvement in performance with better indoor air quality, I think that's a really good place to start. And so I hope we can see more building interventions and policies, whether they're at, some type of governmental level or just the building level, adopted.
Yeah, no, that absolutely makes sense. I think what indoor air quality, or just air quality in general, it's one of those things. It impacts every single one of us, right?
Mm.
We are all breathing all the time, and it impacts us in so many different ways. There's the long-term health impacts. Just to put a number out there, the estimates of deaths in India that are attributable to air pollution, depending on the year, between around 17.5 to 18.5%. That is an enormous number.
Yeah.
That's the long-term health impact. There's the short-term health impact from a lot of pollutants. There's the short-term impact on productivity. There's just comfort, transmission of viruses. I mean, there are so many different impacts to each of us as individuals. There is also, such a wide range of impacts, I feel like, to different businesses, workplaces, schools. And so we've talked for a while here about creativity specifically. Outside of that, there's more broader cognitive function. Outside of that, there is a whole host of good air equals fewer sick days, fewer people getting sick, equals more productivity for a business, equals scale that up to across the global economy, huge savings. Scale that up further, huge savings on the cost of healthcare for all of these people that can be suffering from the consequences of poor air quality. I think something that's really important, and that certainly I've been trying to do a lot of work on recently, is trying to understand the different groups within, be it a business, be it a school, be it government, and how they are each impacted by these different metrics, and what the right way to translate that is. Because nobody wants to, outside of a small group of people that are really into air quality, many of the people on this call might be, but outside of a small group of people, no one really wants to look at parts per million of CO2 or parts per billion of a certain VOC. It's all about translating this data into something that is measurable and relevant to the things that we each care about in our day-to-day, in our work, and so on. So I guess first of all, just a big thank you to the great work that you're doing to bring in yet another angle that hopefully is going to convince more business leaders or whoever else it might be in the community that this is something that they should really care about. Because air impacts all of us. Everyone's doing a little piece here to move the discussion forward. If we can create enough points where everyone realizes this is really something that we should be caring about more, I think that's incredibly powerful and useful to the planet in general. So thank you for that. Jump to one final question. If people could walk away from this conversation with one key takeaway, one idea, one number, one data point, a message that really sticks, what would it be?
I guess I would say, there's still a lot we don't know about air quality, and a lot of people, I think, well, we do need to do more research, but I think I would say, even though we haven't figured out the exact mechanisms, I think we do see that ventilation and bringing in outside air, it seems to be good at controlling or reducing our exposures to many indoor air pollutants. And whatever that combination is, it seems beneficial to our health and our cognitive performance. So I think you might hear from like different papers or scientists like, oh, we don't know this, we don't know that, it's not this, it's not that. But I still think we're seeing like very consistent evidence that when we bring in outside air to reduce indoor air pollutants, we see benefits to cognitive performance and other health effects. That, thank you for bringing that up, because this is a much broader discussion with a lot more impact beyond just cognitive performance. So my plug is for outdoor air ventilation.
Okay, that's it. That's the takeaway. Outdoor air ventilation. In case you don't remember anything else, remember that. So with that, maybe let's jump to the Q&A. There's a bunch of questions that are already in the Q&A list. So if you want to ask something you haven't had the chance to yet, there should be a bar at the bottom. Click on it, Q&A, type your answers in, and let's start with the first one here. Very straightforward. Is this air quality and cognitive performance score data set publicly available?
The one from our study is not publicly available. It's available upon request. So you can chat with me, or if you'd like to follow the corresponding email, that will also direct you to me or one of the other study members. So we can chat if you have a need for it.
On we've got a slide coming up in a moment, which will have our contact information. So if anyone wants to find Sandra, it will be very easy to do so. Awesome. So next one we got here is, do other pollutants other than CO2 have cognitive impact?
Okay, great question. I'm glad this came up. And sorry, you're going to get a pretty long answer here.
Let's do it.
So yeah, so I should clarify, like every time we've been talking about CO2, CO2 comes up so much in the paper. So CO2, we use it as like an air pollutant that's easy to measure. And it's also affected by ventilation and occupancy. And it's also correlated with other indoor air pollutants that we are not able to measure accurately. So whenever we use CO2 in our work, that's indicative of these other things that are changing in the building as well. So ventilation, occupancy, other correlated air pollutants. So when we use CO2 in our statistical models, you get two things. You get both a potential direct effect of CO2 on cognitive performance, and then they call it an indirect effect, where CO2 might actually be acting on cognitive performance through something else, like say another air pollutant that bounces around with CO2. So we don't actually, when I'm saying like, we have more things to uncover, we actually haven't uncovered, we haven't parsed out, is there this much that's the direct effect? Is there this much that's the indirect effect? And if you go outside of this conversation, a lot of people, including some position documents, will say like there's no direct effect of CO2 on cognitive performance. We could talk about that as well. But so basically right now, this is why I'm talking about the plug for ventilation, because while there are some groups that say CO2 doesn't have an effect, and a lot of people think it's that indirect effect, we really haven't quantified that. So we can't say for certain what's happening here. So that's why I'm also plugging ventilation. And so to answer your other question in a roundabout way, an indirect way, if you will, yes, there are other indoor air pollutants that we should be concerned about. Other things like related to you and I, we give off these bioeffluents and other air pollutants. It's hard to measure them accurately in a way that we can use in this type of research. So very good question, and thank you for bringing that forward.
Yeah, and there's some fascinating research on sort of the topic of human bioeffluents. So if anyone's curious about this, you could be digging for a long time, but there's some really interesting stuff there. One question that I saw pop up, which is kind of tied to this, and I just want to clarify for everybody. Question is, more outside air / more ventilation is definitely contextual, right? You wouldn't want to do that in Delhi? Question mark.
No, that's a very good point. It is contextual. So in this study, in a lot of these studies where we have, Liam, you mentioned it earlier, you said clean, actually, let's call it outdoor air. So in a lot of our contexts, the outdoor air is clean. It has low concentrations, but you are right. In other geographies, bringing in more outdoor air is a challenge. And this is why, when we have that hierarchy, it's source control first, then ventilation, then air cleaning. And then there has been past work that looks at the impact of high performance media filters on indoor particle concentrations in these areas that have the challenge of higher outdoor air pollution. And so they are effective, but you are right that it is still a challenge. And sometimes based on the numbers, it can bring in more outdoor air pollutants.
Yeah, I mean, I think, so I spend a lot of time running around the world in many highly polluted cities. And I spend a ton of time looking at vast sort of data sets and buildings and understanding what's going on with the sort of infiltration of outdoor pollutants. I think it is absolutely possible today to create spaces that are bringing in a high volume of outdoor air while effectively filtering it and responding accordingly when there are major fluctuations in outdoor air pollutants. So in a lot of cities, if we're talking about Delhi, for example, there's actually a very clear pattern in the particulate matter levels. They aren't flat for, at crazy high levels for a long period of time. There are actually times in the day when there are peaks, when there are troughs, and there's a lot that can be done around optimizing building performance based on the rate of change and what's happening with outdoor PM levels, making sure that the building is designed properly. An absolutely key part of this, obviously I have some bias here, but it is measurement, because there's just no way to know if you're making the right decisions if you're not measuring it. And that's especially key in a city that has high outdoor air pollution, because I mean, I'm going on a little bit of a tangent here, but Kytera as a company was started because I wanted to understand indoor air pollution coming from outside, because it was having a personal impact on my family and my own health. And being able to see indoor air quality and PM 2.5 levels was an absolute game changer, because I realized all these things. I was thinking I had to buy more air purifiers in my home to increase the amount, the rate at which we could purify the air. But actually, there were some very simple things that I could do around having better sealed windows to prevent infiltration from the outside, positively pressurizing the space so that, again, particulate matter couldn't get in, using better filtration. There's a whole bunch of steps that are actually pretty low cost and low hanging fruit that can really allow for a high performing space. So all of that to say, you can absolutely bring in more outdoor air, ventilate better, while still delivering clean air to indoor spaces. If you take the right strategies, you measure, and you make sure that nothing in that system is breaking. Because if one thing breaks and you're not measuring it and you don't see it, you rapidly end up with a building that is not doing what it was designed to do. And all of these numbers suddenly go up very, very quickly. So just looking at a couple other questions in here, we've got, just to clarify, under 800 ppm of CO2, you saw declines in creativity, e.g. between 500 and 600 ppm. Even these very low levels, very small increases in CO2, you were seeing changes in creativity. Just want to be very clear on that one for the audience.
Yeah, so we run the models in a way at first where they have flexibility for non-linear associations. So we basically say, like, CO2, you can take on any shape, any behavior you want with the cognitive test scores. And so we look at that across the CO2 exposure range, and we didn't see evidence of any non-linear associations. We just see these kind of straight line associations. So the effect estimates I'm saying, yeah, those are linear estimates. So across the exposure range, it's consistent in this study.
Makes sense. I just see one very quick question there about what day or what time of day do you see the big troughs and peaks, and what's the difference in amplitude when we're talking about outdoor pollutant levels. I don't remember the exact times. I think early morning is when you see, specifically in Delhi, is when you see the biggest spikes, and you will sometimes be looking at 5, 6, 10x differences in PM 2.5 levels. So it's huge. This isn't a small impact. You could have outdoor levels of 30 micrograms that spike up to 500 micrograms per cubic meter. So huge differences. I think we are coming up at time. I'll just see if maybe we got time for one last question. Oh, this is an interesting one. Have you had any interest from government, treasury, and industry departments about the productivity findings? I guess maybe, more broadly, what's been kind of the reaction from the community? What have you heard? Yeah,
great question. I mean, I guess my one of my studies still isn't out from my dissertation. 2 of them are out. I think one we didn't talk about is about we looked at associations between indoor air pollutants and cognitive performance in classrooms with higher ventilation rates for COVID-19 risk management. So that one has received actually a lot of interest offline. I think from the scientific community about some sticking points, and then also from people from these types of organizations interested in using it to inform policy. And then if I go back to when I was in industry and the original COGfx research came out before I was part of the Harvard team, I was shocked. I was so shocked by the reaction and the number of people, whether it's like an independent client, an owner, whatever, interested in making an improvement in indoor air quality. So I think change is happening at different levels. And I think implementation is also a real challenge when it comes to indoor spaces and buildings. So that will be interesting to see how that evolves in the future.
Yeah, absolutely. Well, I think there's a lot of people that are very interested here. So Joe, maybe we can bring up the contact slide, because I know there's gonna be a number of people that are gonna want to reach out to Sandra and get their hands on this information. So I think with that, we'll put this up for a second, and you can find both of our information there to reach out. Again, thank you, huge thank you to everyone who joined us today, and obviously to Sandra for sharing the work that you're doing. I think this is really, really important work. Air pollution, as I said earlier, and poor air quality in general is probably, in my opinion, one of the world's greatest crises that is not having enough attention paid to it yet. I am extremely happy to see more and more and more research, pushing forward the discussion about improving the air that we breathe. So again, huge thank you for joining, sharing all these insights. Now, if this discussion sparked any ideas or questions about, your own workplace, whatever area you work in, how to optimize these spaces to be better supportive for everyone's creativity, their cognitive function, obviously, feel free to reach out, and we'll be sending out a recording of this conversation. If you missed anything, you want to go back and listen to any parts of this and the nitty-gritty numbers, you can do so. Feel free to share this with your team or anyone that you think might be interested. And again, there's the spaces that we design collectively, that we design, that we manage, that we create, that we inhabit every single day. They can do a lot more than just be a roof over our head, allowing us to do basic work. They can really, I think, unlock a lot of human potential, creativity, be wonderful, comfortable spaces that can bring us together. So I think this is really, really important work. Thank you again, and see you next time, everybody.
Thanks, Liam, and thanks everyone for joining.
Thank you all for joining. Thanks, Sandra.
Thank you.
Have a great day.